let's jump right in. Today, we're doing a deep dive into a really powerful security combination, Cisco's SD-WAN and Umbrella. We're going to get into the nuts and bolts of how they work together to stop threats at the absolute earliest moment possible, the DNS lookup. Just think about it for a second. Before any data gets exchanged, before a file ever gets downloaded, before pretty much anything happens online, your computer makes a DNS request. It's basically the internet's phone book. And that makes it the very first domino to fall in almost every single network connection. So logically, it's the perfect place to enforce security. So here's our game plan for this explainer. First, we'll hammer home exactly why DNS is so critical. Then we'll introduce how Umbrella steps in as your first line of defense. After that, we're going to follow a single DNS query on its entire journey, take a look at the massive global infrastructure that makes it all possible, and then wrap up with the practical stuff you need to know to actually implement it. Okay, let's kick things off with Section 1, DNS, the first domino. We really want to reframe how you think about DNS, not just as some background utility, but as a primary choke point for so many modern threats. Now, what's really, really interesting about this is the timing. DNS comes before everything else. It happens before an IP connection is ever made, and way before any malware even has a chance to execute. So, by controlling DNS, you get the earliest possible shot at identifying and blocking a threat before it can do any damage whatsoever. Which, of course, brings us right to our second section, Umbrella, your first defense. If DNS is the attack vector, then Umbrella is specifically designed to be the proactive solution right at that exact layer. And this just shows the concept perfectly. You can think of Umbrella as this huge cloud-based shield. It sits right between your users and all the nasty stuff on the internet. Malware, phishing sites, command and control callbacks, you name it. The crucial part is that it inspects the destination before a connection is ever even established. So how does this actually work on your network? Well, it's all thanks to something called the Umbrella connector. This is a piece of software that lives right on your SD-WAN router. Its entire job is to intercept every single DNS query, get a verdict from the Umbrella cloud, and then act as the local enforcement point. It's the boots on the ground, so to speak. All right, now that we know about the connector, let's get into the really fun stuff. Let's trace the journey of a single DNS query. We're going to follow it from the user's machine all the way to resolution and dig into the technical details of how it all gets inspected. Okay, here's the flow. Your device wants to go to, say, website.com. The Umbrella connector grabs that request. First thing it does is ask, is this an internal resource? If it is, no problem. It just forwards it to your internal DNS server. But if it's for an external domain, it does something really critical. It adds what's called an eDNS record before shooting it off to the Umbrella cloud for a decision. And this eDNS record, this is the secret sauce right here. This isn't just a standard DNS query anymore. It's been enriched with all this critical context. The Umbrella cloud now knows not just what domain is being requested, but who is asking, which organization, which specific device, and from what IP. This is what unlocks the ability to have incredibly granular, identity-based security policies.
So once that query hits the Umbrella cloud, a decision gets made. And it really falls into one of three buckets. If the domain is known to be malicious, bam, Umbrella just responds with the IP of a block page. If the domain is known to be safe, totally benign, it simply returns the real IP of the website. But then you've got this third, really interesting case. If a domain is suspicious, kind of gray, Umbrella sends back the IP of its intelligent proxy.
So this intelligent proxy is a critical piece for those riskier domains. When the user's browser gets this special proxy IP, it sends its web traffic there instead of going directly to the destination. This lets Umbrella do a much deeper inspection of the connection, looking at the specific URL paths, even scanning files for threats before it lets the traffic go through. It's like a selective, deeper security screening for anything that isn't obviously good or bad. Okay, on to Section 4, the Umbrella infrastructure. It's one thing to have all this cool logic, but it's another thing entirely to do it at a global scale without slowing down the internet for all of your users. And this is how they pull it off. Umbrella uses something called anycast routing. It's a really slick idea. Instead of having one IP for one data center, the same exact IP addresses are announced from dozens of data centers all over the world. So when your router sends a DNS query, Anycast just makes sure it automatically goes to the closest and therefore fastest data center to you. This design gives you amazing redundancy and keeps latency incredibly low. And for all you network folks out there who manage these systems, these are the actual Anycast IP addresses your SD-WAN devices will be talking to. These are some of the most well-known and reliable DNS resolvers on the entire internet. All right, let's get to our final section, implementation and policy. This is all about what you, as the network operator, really need to know before you start rolling this out. First up, the prerequisites. You're going to need the right licensing, of course, including a Security K9 license on your device. You'll need an Umbrella subscription and a reasonably modern version of iOS XE software. But maybe the most important thing here is that your SD-WAN device has to be the default DNS gateway for your endpoints. If clients are pointed somewhere else for DNS, their traffic is just going to bypass this protection completely. Now for the constraints, and these are absolutely crucial to understand. First, remember, this is DNS layer security. If an app uses a hard-coded IP address, it doesn't use DNS, so it bypasses this policy. Same thing if you're already using an external web proxy. There are also a few technical limits to know about, like the eDNS record only carrying the host's IPv4 address and a cap on how many local domains you can explicitly bypass. You know, whenever you're layering a bunch of security services together, the order of operations is critical for performance. This diagram shows exactly how Cisco's Secure Internet Gateway, or SIG, evaluates traffic. Let's just walk through it real quick. And the single most important takeaway from that whole flow is this. DNS policies are always evaluated first. Before any other services, like the cloud-delivered firewall or the secure web gateway, even get a look at the packet, a DNS security decision has already been made. The benefit of this is just immense efficiency. By knocking down known bad destinations at the DNS layer, you prevent that traffic from ever having to be inspected by the more resource-intensive firewall or web proxy. You shed all that unnecessary load as early as possible, which lets those other services focus only on traffic that's already passed the first crucial security check. It's just a smarter, faster way to apply security. And that really brings us to our final thought. As we're talking right this very second, your network is just humming with thousands of DNS requests. It's the foundation of everything your users are doing. So the question is, do you really know where they're going? Do you have the visibility and control at that foundational layer to stop the next threat before it even gets started? Thanks for joining me.